Today we're going to go through solving one-step inequalities. Remember, the goal is to isolate the variable just like we did when we solved equations. To do so, we will use the inverse operation and balance the inequality. So let's look at number 1. E plus 15 is greater than or equal to 27. So we are going to solve this to find all the values that E can be to make this inequality true. Well, first, let's look at our variable. Which operation is happening to the variable? E and 15 are being added together. So the inverse operation of addition is subtraction. So we need to subtract 15 from both sides of the inequality. 15 minus 15 make a 0 pair. So the only term remaining on the left side is our variable. Bring our inequality symbol straight down and do the math. 27 minus 15 is 12. So our inequality is E is greater than or equal to 12. That means E can be any value that's 12 or greater. When we graph it just like we learned earlier. Would this need an open or closed circle? It needs a closed circle at 12 because 12 is included. To the left of 12 is 11, to the right of 12 is 13. If we want all values that are greater than or equal to 12, our arrow should go to the right. So any value that's 12 or greater than 12 will make this inequality true. Let's do another one. 34 and 5/10 is less than n minus 23. Now, even though the variable is on the right side of the inequality, does that change our steps? No, we still need to isolate the variable using inverse operations. So which operation is happening to the variable? 23 is being subtracted, so the inverse operation of subtraction is addition. So we need to add 23 to the right side and to the left side. When we do it on the left side, we need to make sure to follow our decimal rules. So what should we do with our decimals? We need to line up our place values. And remember, 23 is like 23 and 0/10. Now let's do the math. Bring my decimal straight down. Bring my inequality straight down. Now on the right side, negative 23 or minus 23 plus 23 make a 0 pair. So we are only left with n. So when we read this, 57 and 5/10 is less than n, which is the same thing as n is greater than 57 and 5/10. These two inequalities mean the same thing. Now let's graph it. Well, since I need to include 5/10, I'm going to label my number line 57, and I'm going to count by 5/10. So this would be 58. Well, what type of circle do we need to use? An open circle, because 57 and 5/10 is not included in our solution. And if we want values that are greater than 57 and 5/10, our arrow needs to go to the right. So any value greater than 57 and 5/10 would make this inequality true. So what are some possible solutions for n? N could be 58, it could be 75, it could be 100. It could even be 57 and 6/10. Could n be 57 and 5/10? No. Remember, that value is not included in the solution set. Let's go to the next inequality. 8a is less than or equal to 96. Remember our goal. The goal is to isolate the variable. So let's look at our variable a. What operation is happening to a? It is being multiplied by 8. The inverse operation of multiplication is division. So we need to divide 8a by 8. And what you do to one side, you must do to the other. So we're going to divide 96 by 8. Now what happens to 8a divided by 8? Well, 8 divided by 8 is 1. So we are left with 1a. We can just write a. Bring our inequality symbol straight down. And then do the math. 96 divided by 8 is 12. So this inequality solution would read a is less than or equal to 12. So when we graph it on our number line, we need 12 in the middle, 11 is to the left, 13 is to the right. Do we need an open or closed circle? We need a closed circle. And if a can be any value less than or equal to 12, in which direction should the arrow go? To the left. So what are some possible solutions for a? A could be 12. It could be 11, 0. It could even be -3. In fact, it could be any negative value. Could a be 13? No, because 13 is not less than or equal to a. Now let's do the last example. What operation is represented in this inequality? When you have a variable over a value, it looks like a fraction, and we know that operation is division. So m divided by 3 is greater than 15. So remember, our goal is to isolate the variable, and we need to use inverse operations. So what operation is happening to m? It is being divided. So the inverse operation of division is multiplication. So we need to multiply both sides by 3. Now remember, to make a whole number a fraction, we can just put a 1 in the denominator. Now let's balance the inequality. If we multiplied by 3 on the left side, we need to multiply by 3 on the right side. Now let's do the math. Over on the left side, when we multiply these fractions, we would technically multiply straight across. So 3 times m is 3m. 1 times 3 is 3. What do we know will happen with the 3 divided by the 3? It makes 1. So we are left with just m. Bring down your inequality symbol. Do the math. 15 times 3, the product is 45. So our solution is m can be any value greater than 45. So when we put that on the number line, I'm going to put 45 in the middle. I'm going to decide to count by a scale of 5 on this one. So notice my number line is 40, 45, 50. What type of circle do we need? We need an open circle because 45 is not included. And in which direction are values greater than 45? To the right. So m can be any number greater than 45. What are some possible solutions for m? 50, 70, 120, any number greater than 45. What are some values that are not in the solution? 40 would not make the inequality true. 45 would not make the inequality true. Remember, we have an open circle, so 45 cannot be in your solution set. I hope this helps you with solving inequalities today. Remember, the goal is just like equations. We need to isolate the variable, and we need to do that by using inverse operations and balancing the inequality. Have a great day.